Licensing requirements for electrical panel building differ depending on the specific location. Generally, most jurisdictions mandate at least an electrical contractor's license to install, modify, or repair electrical panels. However, certain states may have specific licensing requirements tailored for control panel builders. To successfully build complete control panels, it is essential to possess PLC programming experience. This typically involves specialized training and certification provided by the PLC manufacturer. A thorough knowledge of electrical panel design and assembly is also required. This includes understanding electrical code requirements, selecting appropriate components, and implementing proper wiring practices. In the United States, the National Electrical Code does not have specific requirements for control panel building. However, state and local regulations do apply, and licensing requirements vary by state and locality. In general, an electrical contractor's license is necessary. Some states may require additional certification specifically for control panel builders. In Canada, the Canadian Electrical Code mandates a master electrician license for all electrical work, which includes control panel building. In the United Kingdom, the Electricity at Work Regulations 1989 requires all electrical work to be carried out by a qualified electrician, and control panel building is generally classified as electrical work. Within the European Union, IEC 60204.1, which addresses the safety of machinery and the electrical equipment of machines, requires that control panels be designed and built by qualified personnel. For a comprehensive understanding of electrical panel building and control panel wiring and programming, consider the following steps. Firstly, obtain an electrical contractor's license or equivalent certification. Secondly, train in PLC programming from the manufacturer. Thirdly, gain experience in electrical panel design and assembly. Fourthly, consider obtaining additional certification in control panel building if required in your jurisdiction. And fifthly, establish a business and obtain the necessary permits and licenses to operate. Gaining an electrical contractor's license typically involves meeting specific requirements, which can include passing an examination demonstrating a certain level of experience and possessing the necessary insurance coverage. The specifics of these requirements will vary depending on the state or locality. PLC programming training from the manufacturer is crucial because it provides you with the specialized knowledge and skills needed to program and troubleshoot PLC effectively. This training often covers topics such as PLC hardware, software, programming languages, and communication protocols. Hands-on experience in electrical panel design and assembly is invaluable because it allows you to apply your theoretical knowledge to real-world situations. This experience can be gained through apprenticeships, on-the-job training, or formal educational programs. Consider obtaining additional certification in control panel building if it is required in your jurisdiction. This certification can demonstrate your expertise and competence in the specialized area. Finally, to establish a business and operate legally, you will need to obtain the necessary permits and licenses from your local and state governments. These permits and licenses may include a business license, a tax identification number, and other permits specific to the electrical contracting industry. Additional information on electrical panels and relevant codes. The National Electrical Code, or NEC, is a widely adopted standard in the United States for safe electrical installations. While it doesn't have a dedicated section solely for control panel building, several articles within the NEC are relevant to the design, installation, and wiring of control panels. Some of these include Article 312, which covers cabinets, cutout boxes, and meter socket enclosures; Article 408, which addresses switchboards and panel boards; Article 430, which pertains to motors, motor circuits, and controllers; and Article 670, which focuses on industrial machinery. When building control panels, it's crucial to adhere to the NEC requirements for conductor sizing, overcurrent protection, grounding, and wiring methods. These requirements ensure the safety and reliability of the electrical system. The Canadian Electrical Code, or SEC, serves as the electrical safety standard in Canada. Section 28 of the CC specifically addresses control and signaling circuits. It outlines the requirements for the design, installation, and protection of control circuits used in various applications, including control panels. The CEC emphasizes the importance of proper overcurrent protection, conductor sizing, and wiring methods to minimize the risk of electrical hazards. Compliance with Section 28 is essential for ensuring the safe operation of control panels in Canada. In Europe, IEC 61439 is the standard for low-voltage switchgear and control gear assemblies. This standard provides comprehensive guidelines for the design, construction, and testing of control panels. IEC 61439 covers various aspects, including mechanical design, electrical characteristics, and protection measures. It also specifies requirements for documentation, marking, and testing to ensure the quality and safety of control panels. Adhering to IEC 61439 is essential for manufacturers and installers of control panels in Europe. Within the United Kingdom, the Electricity at Work Regulations 1989 places a legal duty on employers and employees to ensure the safety of electrical systems in a workplace. These regulations require that all electrical work, including control panel building, be carried out by competent persons. Competent persons are individuals who possess the necessary skills, knowledge, and experience to perform the work safely. The regulations also emphasize the importance of regular inspection and maintenance of electrical systems to prevent electrical hazards. Furthermore, the Provision and Use of Work Equipment Regulations 1998, or EAWR, places requirements on the safety of work equipment, including control panels. EAWR mandates that work equipment be suitable for its intended purpose, properly maintained, and used safely. Control panels must be designed and constructed to minimize the risk of injury to operators and maintenance personnel. Control panel design considerations. When designing control panels, it's important to consider several factors to ensure their safety, reliability, and functionality. These factors include component selection, wiring practices, overcurrent protection, grounding, and environmental considerations. Choosing the right components is essential for the performance and longevity of the control panel. Components should be selected based on their suitability for the intended application, their electrical ratings, and their ability to withstand the environmental conditions in which they will be operating. Proper wiring practices are crucial for ensuring the safe and reliable operation of the control panel. Wires should be properly sized, insulated, and terminated. Wiring should be neat, organized, and securely fastened to prevent damage or disconnections. Overcurrent protection devices, such as fuses and circuit breakers, are essential for protecting the control panel from overloads and short circuits. Overcurrent protection devices should be selected based on the ampacity of the conductors they are protecting and the interrupting rating of the circuit. Grounding is critical for preventing electrical shock hazards and ensuring the proper operation of sensitive electronic equipment. The control panel should be properly grounded to a suitable grounding electrode system. Environmental considerations such as temperature, humidity, and dust can affect the performance and lifespan of control panel components. The control panel should be designed to withstand the environmental conditions in which it will be operating. This may involve using components with appropriate temperature ratings, providing ventilation to prevent overheating, and sealing the enclosure to protect against moisture and dust. Safe work practices when working with electrical panels. Working with electrical panels can be hazardous if proper safety precautions are not taken. It's important to follow safe work practices to minimize the risk of electrical shock, arc flash, and other electrical hazards. Some essential safety practices include always energizing the circuit before working on electrical panels, using appropriate personal protective equipment, or PPE, such as insulated gloves, safety glasses, and arc-rated clothing, and never working alone, having a qualified person present to provide assistance in case of an emergency. Also, verifying that the circuit is de-energized using a voltage tester before touching any conductors or components, following lockout-tagout procedures to prevent accidental energization of the circuit, and maintaining a safe working distance from energized parts. Additionally, being aware of the potential hazards of arc flash and taking steps to minimize the risk, such as using arc-rated PPE and maintaining proper clearances, and receiving adequate training on electrical safety and safe work practices. Regarding control panel maintenance, regular maintenance is essential for ensuring the continued safe and reliable operation of electrical panels. Maintenance tasks include inspecting the panel for signs of damage or wear, such as loose connections, frayed wires, or corroded components, tightening all connections to ensure proper electrical contact, cleaning the panel to remove dust, dirt, and other contaminants, testing overcurrent protection devices to ensure they are functioning properly, and verifying that the grounding system is intact and effective. Also, replacing any damaged or worn components, such as fuses, circuit breakers, or wiring, and keeping accurate records of all maintenance activities. Control panel troubleshooting includes the following steps: visually inspecting the panel for any obvious signs of problems, such as loose connections, burnt components, or damaged wiring, using a multimeter or other test equipment to check voltages, currents, and resistances, consulting the control panel wiring diagram to trace circuits and identify potential faults, checking the operation of relays, contactors, and other control devices, and replacing any faulty components. Also, consulting with experienced electricians or technicians for assistance with complex troubleshooting tasks. Remember, working with electrical panels can be dangerous. Always follow safe work practices and seek assistance from qualified professionals when needed. Additional resources that may be useful for electrical panel building and licensing information include the National Electrical Code, or NEC, the Canadian Electrical Code, or SEC, the Electricity at Work Regulations 1989, and the IEC 61439 standard. Also, state and local licensing boards, electrical trade associations, and educational institutions offering electrical training programs can be great sources of information. Remember to always consult with qualified professionals for specific advice and guidance on electrical panel building and licensing requirements in your area. Staying up to date with the latest codes and regulations is essential for ensuring compliance and safety. The specific requirements for control panel building can vary based on the application. For instance, control panels used in hazardous locations, such as those with flammable materials, require special design considerations and certifications to prevent explosions. Similarly, control panels used in critical infrastructure, such as hospitals or power plants, may have stricter requirements for reliability and redundancy. The type of equipment being controlled also influences the control panel design. Control panels for motor control applications will differ from those used for process control or lighting control. Motor control panels, for instance, often include components like motor starters, variable frequency drives, and overload relays. Process control panels, on the other hand, may incorporate programmable logic controllers, or PLCs, human-machine interfaces, or HMIs, and various sensors. Lighting control panels typically consist of switches, dimmers, and lighting contactors. The complexity of the control system also affects the control panel design. Simple control systems may only require a few basic components, while complex systems may involve hundreds or thousands of components. Complex control systems often utilize PLC to manage the control logic and HMI to provide operators with a user-friendly interface. The size and layout of the control panel are also important considerations. The control panel should be sized appropriately to accommodate all the necessary components and wiring. The layout should be designed to facilitate easy access for maintenance and troubleshooting. Proper wire management is essential for maintaining a neat and organized control panel. Wires should be properly bundled, labeled, and secured to prevent damage and ensure easy identification. The control panel enclosure should provide adequate protection for the components inside. The enclosure should be rated to protect against environmental factors such as dust, moisture, and temperature extremes. The enclosure should also provide physical protection against impact and vandalism. Control panel testing is an essential step in ensuring the proper functioning and safety of the panel. Testing should be performed before the panel is put into service to verify that all components are working correctly and that the wiring is properly connected. Testing may involve visual inspection, continuity testing, voltage testing, and functional testing. Control panel documentation is crucial for providing information about the design, installation, and maintenance of the panel. Documentation should include wiring diagrams, component lists, and operating instructions. Documentation should be kept up to date and readily available to authorized personnel. Control panel modifications should be carefully planned and executed to ensure that the panel continues to operate safely and reliably. Modifications should be performed by qualified personnel following proper procedures. All modifications should be documented, and the wiring diagrams and component lists should be updated accordingly. Control panel upgrades may be necessary to improve performance, add new features, or replace obsolete components. Upgrades should be carefully planned to minimize downtime and ensure compatibility with existing equipment. Upgrades should be performed by qualified personnel following proper procedures. Control panel retrofits may be required to bring older panels into compliance with current codes and standards. Retrofits may involve replacing components, upgrading wiring, and adding safety features. Retrofit should be performed by qualified personnel following proper procedures. Control panel disposal should be done responsibly to minimize environmental impact. Components should be recycled whenever possible, and hazardous materials should be disposed of properly. Control panel safety training is essential for personnel who work with or around control panels. Training should cover topics such as electrical safety, arc flash hazards, lockout-tagout procedures, and proper use of personal protective equipment. Control panel safety audits should be conducted periodically to identify potential hazards and ensure that safety procedures are being followed. Audits should be performed by qualified personnel. Control panel safety culture is essential for creating a safe working environment. A strong safety culture encourages employees to report hazards, follow safety procedures, and participate in safety training. Control panel safety leadership is crucial for setting the tone for safety within an organization. Leaders should demonstrate a commitment to safety and provide the resources and support needed to create a safe working environment.